The new millennium is in full swing, and with it comes Mitsubishi Motors 2001 model year vehicles. In this program, we'll take a look at the technical changes throughout the entire model line, plus a recap of two newcomers released earlier in the year, the all-new Eclipse Spyder and Montero. The goal of this self-study program is simple. We want to quickly get you up to speed on the key technical changes that impact your product knowledge and your ability to service your customers' vehicles right the first time, every time. We've organized this program into modules, each with its own set of learning objectives. The objectives in each module help direct your focus to the most important points of the program. By checking your knowledge against these objectives, you'll be able to identify any areas that are unclear and should be reviewed again. You'll also find individual modules are easier to navigate when looking for specific information. If you're watching this program in CD form, you'll have to change CDs after Module 4. The VHS format has the complete program on one tape. So, get ready. Once you finish this program, you should be able to identify the main technical changes to the 2001 model lineup, explain the benefits of the key technical changes, recognize the operational highlights and main service points of the new technology added for 2001, identify the general steps of appropriate child safety seat installation and the importance of properly securing a child in a safety seat, and finally, how to access and navigate Mitsubishi's technical training website. When you're confident of your new model knowledge, you'll be able to test your skills for self-study course credit. More on that at the end of the program. Let's get started.
In this module, we'll introduce the 2001 model line and the main technical changes to each vehicle. After completing this segment, you should be able to identify all the main technical changes for 2001. Before examining each model individually, let's take a look at the changes affecting the entire model lineup. All MMSA vehicles meet Low Vehicle Emission, or LEV, standards in California, as well as the National Low Emissions Vehicle NLEV standards in the remaining states. The Galant 2.4-liter goes even further by meeting the Ultra-Low Emission Vehicle ULEV standards for California only. So what does this mean during service? Simple. LEV emission standards are 70% less hydrocarbons than the basic standard in California. NLEV standards are 70% less hydrocarbons than the federal basic standard, and ULEV standards are 85% less hydrocarbons, 50% less carbon monoxide, and 50% oxides of nitrogen than the California basic standard. This is good to know for emission inspection as well as engine performance troubleshooting. As you can see, our vehicles are emitting less pollutants in order to comply with increasingly stringent emission standards. Check the under-the-hood label to identify which system is equipped on the vehicle. The next change applies to the 4050 series transaxles in the Mirage, Eclipse, Galant, and Diamante. All F4A41, F4A42, and F4A51 automatic transaxles no longer utilize an external sub-oil filter. Since the transaxles now use Diamond ATF SP3 fluid, the external filter is no longer required. That's a time savings for you and a cost savings for your customers. This was actually a running production change during the 2000 model year. Refer to Technical Service Bulletin TSB 00-23-003 for details. Now let's take a look at each 2001 model individually. The Mirage returns as a coupe in either DE or LS trim levels, while the sedan is available as either an ES or LS. In addition to the emission and automatic transaxle changes mentioned earlier, the only other enhancement is the addition of a child restraint anchor for increased protection and safety. The Eclipse Coupe joins the lineup in RS, GS, and GT trim levels. The all-new Eclipse Spyder burst onto dealer lots just a few short months ago. We won't go into detail here as this vehicle is covered in an all-new Eclipse Spyder technology training course and video. You should know that there have been several changes to the convertible top, seals, and window regulators, So be sure to complete the video program or technical training course in order to become familiar with the details. You'll find that all V6 models utilize a single piston front disc brake caliper. It has a larger piston that provides the necessary braking force, but it's easier to service than the two-piston type. The 2001 Galant continues to be available in two four-cylinder models, the DE and ES, and three V6 models, the ES, LS, and GTZ. Other updates include the relocation of the front catalytic converter to the exhaust manifold on 2.4-liter models, and a lower child anchor support added on the rear floor. A dual-type radiator fan replaces the single type previously used. For the 2001 model year, Diamante continues with an ES and an LS model. Both models meet both the federal and California emission standards. New features include a child restraint added to the rear shelf panel and a new SRS ECU part number because of a vendor change. Fog lamps have been added to the LS model as standard equipment. Now let's turn our attention to the 2001 Montero Sport. The model lineup includes the ES, which is now available in two- or four-wheel drive, the LS, the XLS, and the Limited or LTD. A special edition will be available this fall. All models meet both the federal and California emission standards, and onboard refueling vapor recovery, or ORVR, is being phased in as standard equipment. Along with some structural and cosmetic enhancements, new features include a new seatbelt tensioner, upper and lower child restraint anchors, and a security indicator inside the combination meter to enable you to perform the immobilizer brake override procedure. The all-new, completely redesigned 2001 Montero features a unibody construction with four-wheel independent suspension for improved ride quality and handling. It is available in XLS and Limited models. It features a large, lightweight plastic front bumper and distinctive grille, with the composite headlights and turn signals molded into a single housing. Custom fog lamps are standard on the Limited and optional on the XLS. Notice that the wheel cut and side moldings are all flexible from front to rear. This helps cut down on unwanted dings and paint scrapes, and the remote-control door mirrors are a new aerodynamic shape to help eliminate undesirable wind noise and to help keep rain from adhering to the glass while driving. Heated door mirrors are optional on all models. Moving to the rear, notice the large bumper. This is a three-piece sectional unit with a metal-plated center section and side sections made out of plastic. Both the front and rear bumpers are designed to securely guard the left and right corners of the vehicle. The spare tire has been relocated for improved visibility, and the rear window features an intermittent wiper with a fixed intermittent period. However, when you move the gear selector to reverse with the wipers operating, the wipers quickly make two full sweeps to clear the back window, then return to intermittent operation. The new rear window washer has a flat spray nozzle to reduce the number of cycles necessary to clean the window. In the interest of ecology, plastic components are marked to identify the type of synthetic used in manufacturing for the purpose of recycling, as on other Mitsubishi vehicles. Entry to the Montero is easier because of a lowered height and new side steps. Once you're inside, notice that front seat occupants are protected by three-point seat belts with pre-tensioners and force limiters, as well as front and side airbags. Looking at the instrument panel, notice that all instruments can be easily viewed by the driver, and all controls are within easy reach, and a new LCD information center with a color display has been added for convenience. The display includes a thermometer, a digital quartz clock, a compass, and running information. While the compass is new, programming is the same as 2000 model year vehicles. On vehicles equipped with automatic air conditioning, current setting readouts are also displayed. Your customers will be glad to know that an anti-theft immobilizer system has been added as standard equipment. With this system, however, it is not necessary to replace the immobilizer electronic control unit when the powertrain control module is replaced. In the rear, the third seat has been changed from jump seats to a foldable, removable bench seat. Notice that the seat folds flush with the floor for extra cargo space. Now let's look at some of the important technical changes that have taken place on the new Montero. The 6G74 S4 3.5-liter engine is the only power plant for all models. To simplify maintenance, a serpentine belt and an auto tensioner with a wear indicator has been adopted. The auto tensioner and tensioner bracket contain reference marks to indicate if the belt is stretched beyond limits. If the belt is within specifications, the single mark on the auto tensioner should be positioned between the two reference marks on the bracket. A larger fan and pulley are used, enabling the fan to turn slower, reducing engine noise. An easily serviced two-piece fan shroud has also been adopted. Cooling system upgrades include a radiator that features a larger core, but with a thinner wall and fins to reduce weight and improve cooling efficiency. Because of the serpentine belt arrangement, with the belt riding on the back side of the fan pulley, the fan turns in the opposite direction of crankshaft rotation. The engine control module and transmission control module have been combined into a powertrain control module, or PCM. Two AT oil coolers are used as in previous years. One is a separate external air-to-air cooler mounted in front of the radiator, and the other is built into the radiator. The engine oil cooler is located here, just behind the radiator. The air conditioning, receiver, dryer, and condenser are integrated like the Eclipse and Galant AC system. A rear heating and air conditioning unit is now available. It is mounted under the rear cargo floor. This combined unit is controlled by a separate control panel behind the center console. It provides a rear vent air mix. Outlets are provided in the floor area and in the roof to provide heated or cooled air to passengers in the second or third row seats. The fuel supply is now kept in a newly designed fuel tank that is located on the passenger side near the center of the vehicle. To guard the tank, a lightweight, highly corrosion-resistant underprotector has been installed. To decrease the weight and increase reliability, the fuel tank features a fuel pump module with the pump and filter integrated into one unit. The fuel pump module can be accessed by first removing a panel under the second seat. The rollover and two-way valve functions are combined into one valve assembly, and their function has not changed. For convenience, one-touch, quick disconnect connectors are used. To couple engine torque to the wheels, the 2001 Montero is available with either a V4A51 4-speed automatic transmission, which is the same AT used in the Montero Sport, or a new 5-speed V5A51 automatic transmission. Both of these transmissions require Diamond ATF SP3 fluid. We'll show you the details of the new 5-speed transmission in Module 2 of this presentation. Both transmissions are equipped with a second-generation Intelligent Innovative Vehicle Electronic Control System, or INVEX 2, which consists of two functions: optimized control to match gear selections to the needs of the average driver under various road conditions, and learning control to modify the timing of the gear shifts in response to the driver's preferences. To keep the fun-to-drive feel of a manual transmission, a new Sportronic shift controller has been added on 5-speed automatic transmission models. This unit allows you to swiftly upshift and downshift, even with your foot on the throttle. This is similar to the shifter introduced on the 2000 Eclipse. To enter Sport mode, move the shift selector lever to drive, then move it to the right. To upshift, bump the shift lever forward. Each bump upshifts the transmission one gear. Bump the lever to the rear, and the transmission downshifts. The numbered indicator lights in the combination meter confirm the current shift position. The operation and limitations on this shifter are essentially the same as the Eclipse. Coupled to the 5-speed automatic is a new active track 4WD2 shift-by-wire transfer case that uses a planetary gear set with a viscous coupler as a center differential. This next-generation technology includes an electrically driven selector system which is controlled by the transfer case ECU. We'll show you how that works in Module 3 of this presentation. Moving back to the rear propeller shaft, you'll notice that it is made of a carbon fiber reinforced plastic material, referred to as CFRP, with a steel Burfield CV joint at each end. The shaft is designed to collapse in a collision that would cause the engine and transmission to move rearward. This action allows the body structure to absorb the impact force of the crash. Since this prop shaft is made of CFRP, it requires special handling because if it is damaged, it can develop fine cracks that can cause the shaft to break. If the propeller shaft drops on the ground, becomes scratched, or is subjected to shock, it must be replaced. When working with the propeller shaft, wrap the shaft tube with a rubber sheet to protect it, and follow the warnings and inspection procedures listed in the service manual. Now let's look at some of the chassis improvements. In order to keep the power on the road, we've redesigned the Montero suspension system. The front suspension is a double wishbone independent design with coil springs, replacing the torsion bars used in previous models. Caster and camber are adjusted by rotating eccentric cam bolts that connect the lower control arms to the subframe. Shims are no longer required. In the rear, you'll find a fully independent multi-link design using coil springs and a stabilizer bar to improve the handling and ride characteristics over the previous design which used a solid rear axle. Camber and toe are fully adjustable using eccentric cam bolts. The camber adjustment eccentric is located in the lower control arm, and the toe eccentric is located in the toe control arm. In the steering system, the recirculating ball-type steering gear has been replaced by a rack and pinion assembly. A check valve is installed in the high-pressure inlet side of the hydraulic control unit to minimize vibrations and kickback felt in the steering wheel under rough road conditions. A rack and pinion with a variable pitch gear ratio will be phased in this year. With the variable pitch gear, a ratio from 19.5 to 1 to 16.4 to 1 is achieved by varying the shape and pitch of the teeth on the steering rack. The teeth on the ends of the rack have a different contact area with the pinion than do the teeth in the center of the rack. This has the effect of changing the gear ratio so that the steering is less sensitive when driving in a straight line and more responsive when turning corners. Another important technical addition is a new hydraulically assisted brake booster system. This system has 6 advantages over a vacuum-assisted brake system. First, the boost function is always stabilized because it is controlled by an electric pump rather than manifold vacuum. Second, vacuum hoses are eliminated. Third, brake response is quicker, especially during panic braking. Fourth, the hydraulic brake booster is smaller than vacuum boosters. Fifth, there are fewer brake lines because the master cylinder, booster, reservoir, and accumulator are integrated into one compact unit. And sixth, when the system has a malfunction, a buzzer sounds and the brake warning lamp comes on. It is important to note that special brake bleeding procedures are required. We'll cover those procedures in Module 4 of this program. In addition to optimized braking response, the mechanical proportioning valve has been replaced by an electronic brake force distribution, or EBD system, programmed in the ABS ECU. The EBD system operates the solenoid valves in the hydraulic unit to control braking output in response to road and load conditions. EBD is canceled whenever ABS is operating. Here's a service brake item we think you'll like. Each brake rotor can now be easily separated from the hub assembly. For 2001, Montero joins the Diamante, Eclipse, and Galant with a simplified wiring system, or SWS. The Montero system operates similar to the Eclipse and Galant SWS system. However, on the Montero, the LCD Information Center is included as part of the SWS. We've covered a lot in this module. Let's take a moment to recap the highlights. All Mitsubishi vehicles meet NLEV, Federal Emission Standards, and LEV, California Standards. The Galant meets ULEV standards for California and NLEV standards for the remaining states. The AT subfilter is no longer required on all F4A40 and 50 series transaxles because of the use of Diamond ATF SP3 fluid. The front catalytic converter has been moved to the exhaust manifold on Galant 2.4-liter models for faster converter warm-up, and new, easier-to-service single-piston front brake calipers are used on Eclipse and Galant V6 models. 2001 Montero technical changes include a unitized body construction for improved occupant protection, engine cooling system upgrades that include a larger radiator, larger fan, pulley and serpentine belt for increased cooling and quieter operation. The AC condenser and receiver dryer have been combined into a single assembly. Fuel system changes include a new fuel tank mounted on the passenger side with a module containing the pump and filter and one-step quick disconnect fittings. A new 5-speed automatic transmission with a Sportronic shifter and a shift-by-wire transfer case. Engine torque is transferred to the wheels through a new CFRP propeller shaft. Careful handling is required. The new rack and pinion replaces the recirculating ball-type steering gear. A variable ratio rack and pinion will be phased in this year. Both independent front and rear suspension feature eccentric wheel alignment adjustments. The new combined hydraulic brake booster and ABS has an electronic brake force distribution system that is controlled by the ABS ECU and eliminates the mechanical proportioning valve. The electrical system has been upgraded with a simplified wiring system that is similar to previous Eclipse and Galant models. We'll cover these topics in more detail in the following modules.
After viewing this module, you will be able to identify the main differences between the V4A51 and V5A51 transmissions, how the 5-speed automatic transmission operates, the locations and names of the hydraulic pressure check ports, and how to adjust the reduction brake band. The V5A51 5-speed automatic transmission is similar in construction to the V4A51 4-speed introduced on the 1999 Montero Sport. To achieve fifth gear, additional components have been added to the rear section of the transmission, including a direct clutch, a reduction brake band, and a one-way clutch. The shift pattern has also been changed to achieve 5 forward speeds and reverse. The direct clutch operates in 4th and 5th gears by connecting the direct planetary carrier and the direct sun gear. The one-way clutch drive, or OWC-D, is a Sprague-type clutch that is effective in 1st, 2nd, and 3rd gears and limits direct sun gear rotation to one direction. When the speed changes, the direct pinion turns counterclockwise. The one-way clutch prevents the direct sun gear from turning clockwise. The reduction brake operates in 1st, 2nd, 3rd, reverse, neutral, and park. It locks the direct sun gear to the transmission case. When you are performing a hydraulic pressure test, you will still use the same pressure checkpoints on the left side that you used on the V4A51. However, you will also need to check these 2 new pressure checkpoints on the right side for the reduction brake and direct clutch pressures. While we are looking at the case, here's a word of caution. This is the anchor bolt for the reduction brake band. It should not be removed during normal maintenance. If you remove this bolt, you will free the band, and you may have to disassemble the transmission to properly re-anchor it. Valve body operation is similar to the V4A51 with the addition of 3 new valves. The reduction brake solenoid valve and the reduction brake pressure control valve, have been added to control pressure to the reduction brake. Fail-safe valve C has been added to shut off pressure to the direct clutch in case of a malfunction in the electronic control system. The reduction brake band is adjustable on the V5A51 transaxle both in and out of the vehicle. The valve body must be removed, and you'll need these two special tools and a 0 to 90 inch-pound torque wrench. Remove the snap ring and the reduction brake cover. Make sure to wear safety glasses. Install the special tool into the cutout area around the reduction brake piston to keep it from turning. Hold the adjusting rod with the special socket, then loosen the jam nut. Using the special socket, tighten the adjusting rod to 87 inch-pounds. Back the adjustment off. Then retighten to 87 inch-pounds again. Next, loosen the adjusting rod 5 1/2 to 5 3/4 turns. Hold the adjusting rod with the special socket, then tighten the jam nut to the specifications shown in the service manual using the special wrench. Now you can remove the special tool from the reduction brake. Lubricate the reduction brake cover O-ring with petroleum jelly. Install the cover and snap ring. Then reinstall the valve body. Now that you have viewed this module, you should be able to identify the new components that have been added to the V4A51 transmission to achieve 5 forward speeds, and the purpose of each component. You should be able to identify the locations and names of the hydraulic pressure check ports that have been added to the V5A51 transmission. And you should be familiar with the procedure used to adjust the reduction brake band. After viewing this module, you will be able to identify the principal components of the SS4WD two-transfer case system, how the transfer case system operates, how to time the shift gears during assembly. The 2001 Montero with the 5-speed automatic transmission includes the Super Select 4WD two-transfer case, which is shifted electronically using a transfer case ECU, an electric motor, and a set of switches. When the driver moves the transfer case shift lever, a switch sends a signal to the transfer case ECU. The transfer case ECU then operates a shift actuator motor to physically move the shift rails in the transfer case in order to achieve 2H, 4H, 4HLC, or 4LLC. The transfer case contains a high-low changeover section, a two-wheel drive, four-wheel drive changeover section, a center differential, a viscous coupling, a front output shaft section, and a rear output shaft section. Whenever you remove the shift gears and/or shift rails, you must line up the timing marks when you reinstall them. If the original timing marks wear off during use, use the following method to relocate them. Start at the area of the gear that has no teeth. Count exactly 10 teeth in either direction on either end of the gear. The 10th tooth is where the timing mark should be. Install each gear so that the timing mark on the gear aligns with the third tooth valley on the high-low and two-wheel drive, four-wheel drive shift rails. Now, let's take a closer look at the transfer case hybrid limited slip center differential that replaces the bevel gear type used on the other models. This unit provides differential action by combining a helical planetary gear set and a viscous coupling unit. It operates very similar to the limited slip differential used on 98 and later Montero Sports, and now offered on the 2001 Montero. The transfer case center differential controls front and rear torque distribution over a variety of road surface and driving conditions. The viscous coupling unit, VCU, is located between the sun gear and annulus gear. The VCU allows drive force changes from 33 to 50% for the front tires and 67 to 50% for the rear tires. The center differential is not serviceable and must be replaced if it malfunctions. The four-wheel drive indicator lamp in the combination meter displays the status of the transfer case. Lamps inside the indicator display two-wheel drive, four-wheel drive, and locked center differential modes. The lamp blinks while gear changeover takes place. When the center differential locks, the center symbol flashes, then burns continuously. If the transfer case goes into fail-safe mode because of a malfunction, the center differential lock symbol flashes continuously at the rate of 1 Hz to alert the driver. We spoke earlier about the new brake system that features a hydraulic brake booster, electronic brake force distribution, or EBD, and ABS. In the next module, we'll see how it works. Now that you have viewed this module, you should be able to identify the principal components of the SS4WD two-transfer case system and how they operate. You should also be familiar with the procedure for timing the shift gears during installation.
For your convenience, this module is divided into 3 parts. Part A describes how the new hydraulic brake system is designed to operate. Part B demonstrates the new brake bleeding procedure, and Part C introduces you to new brake service procedures. After viewing this module, you will be able to identify how the new hydraulic brake booster system is designed to operate, to bleed the hydraulic brake system, and to adjust the parking brake. First, let's look at the components on the hydraulic or HBB unit, starting with the hydraulic fluid reservoir, accumulator, and the electric pump motor. The hydraulic unit Brake booster and master cylinder are combined into one unit. However, it is important to recognize the HBB and ABS are separate systems. The master cylinder provides hydraulic pressure directly to the front brakes. All rear brake hydraulic pressure is provided by the HBB. Pressure from the master cylinder to the front brakes is assisted by the hydraulic brake booster. The hydraulic pressure generated by the brake booster's accumulator is sent directly to the rear brakes. The master cylinder has a single piston with a center valve. The HBB supplies pressure to the front and rear sides of the piston. The front section consists of a regulator piston, a return spring, a spool valve, a reaction rod, and a reaction disc, which changes shape in response to the pressure, in that order. The rear section consists of an operating rod, a power piston, and a booster chamber, in that order. The operating rod and the power piston are directly linked. The regulator piston, which transmits the brake pedal force, and the spool valve are also directly linked. To help you diagnose problems with the new hydraulic brake booster, let's take a little time and look at how it works. The force from the master cylinder is applied to the regulator piston in the forward direction, and the power assist force from the booster is applied to the regulator piston in the reverse direction. This produces a balance between the two via the reaction disc. The result is that hydraulic pressure increases in proportion to the force on the pedal. The regulator piston is equipped with a return spring to maintain the spool return force when there is no power assist force applied by the booster. When the pedal is depressed, the operating rod, power piston, master cylinder piston, regulator piston, and spool valve all move to the left. As the spool valve opens line A and closes line B, hydraulic pressure from the accumulator supplies the rear brakes. This pressure also affects the booster chamber and provides power assist to move the master cylinder piston to the left. When the pressure in the booster chamber increases, the pressure applied to the rear of the reaction discs starts to change its shape. The reaction disc contacts the reaction rod, and the reaction rod in turn contacts the spool valve. The pressure from master cylinder reservoir on the left and booster pressure on the right is brought into balance by the reaction disc. This maintains a consistent level of power assist hydraulic pressure generated by the brake pedal. If there is a loss of accumulator pressure because of a pump motor malfunction, let's say, only the front brakes will operate. The HBB pump uses two relays, each acting as a backup for each other. The circuit also includes motor relays, HBB buzzer, and the brake warning lamp. The HBB and ABS ECU communicate service information to the scan tool through the data link connector, or DLC. Let's take a look at the system's components in detail. An electric pump motor supplies the accumulator with hydraulic fluid. The accumulator is a storage tank that is pressurized with nitrogen gas. It collects the hydraulic fluid under pressure from the electric pump motor. The HBB uses two types of pressure switches, one for pump control and the other to warn of low pressure. They are both contained in the HBB and are not serviceable. When accumulator pressure drops below a specified amount, approximately 219 psi, the pressure switch for pump control switches off, and the ABS ECU makes the pump motor operate. This pressurizes the brake fluid, which discharges through the check valve and is stored in the accumulator. This operation generates the hydraulic pressure, high pressure, required for normal brake operation. When accumulator pressure drops too low, approximately 157 psi, the pressure switch for low pressure warning switches off. This causes the brake warning lamp to light and the HBB buzzer to sound. When the hydraulic pressure from the accumulator rises to normal operating pressure, approximately 251 psi, the pressure switch for pump control switches on. After approximately 1 second, the pump motor stops. If the pressure switch has a malfunction, the relief valve opens, approximately 348 psi, to prevent excessive pressure from building up. The HBB reservoir is equipped with brake fluid supply ports for the pump motor, the master cylinder, and the HBB, as well as fluid return ports to allow fluid to return from the booster and the various solenoid valves. A brake fluid level warning switch is built into the reservoir. 2 motor relays control the pump motors according to signals from the ABS ECU. If one relay malfunctions, the other will operate the pump motor. The HBB buzzer sounds and the brake warning lamp illuminates according to signals from the ABS ECU when there is a malfunction in the system. The ABS is a 4-channel system with each wheel having its own pressure solenoid valve. Like the Montero Sport, it operates like a 3-channel system using the select low principle. The system controls the front wheels independently and the rear brakes are controlled as a unit. However, during turns, the ABS ECU senses the turning condition using signals from the wheel speed sensors, causing the ABS ECU to control all wheels independently. This method improves vehicle braking performance, especially when turning. The ABS hydraulic parts are integrated into the HBB. An EBD function is added to the ABS ECU software. This takes the place of a mechanical brake proportioning valve. The system provides the optimum rear wheel braking force regardless of the vehicle load and the condition of the road surface. The system reduces the required pedal force, particularly when the vehicle is heavily loaded or when driving on high-friction road surfaces. EBD uses the rear ABS solenoid valves to control rear hydraulic pressure to optimize the braking force. EBD operates in the area where ABS does not operate. When the ABS system activates, the EBD function deactivates. Notice on the chart that during both EBD and ABS operation, as the rear wheel speed decreases, the rear brake pressure also decreases. However, the front wheel brake pressure, which is controlled by the master cylinder and the HBB, increases as wheel speed decreases. After viewing this section of the module, you should be able to identify the main components of the HBB and how the system is designed to operate under various conditions. Remember that although the HBB and ABS hydraulics are combined in a single unit, they operate independently. The HBB brake system requires special bleeding techniques. Always refer to the service manual for the complete bleeding procedure before starting, and make sure that you keep the fluid level between the min and max marks during bleeding. And don't forget your safety glasses. Now, here are the highlights. Bleed the front calipers in the conventional manner by having an assistant hold the brake pedal down while you open the bleeder valves. Next, bleed the HBB accumulator by turning the ignition on to prime the HBB pump. If the pump sounds dry, pump the brakes 3 to 4 times. When the motor stops, check the reservoir for air bubbles. If there are bubbles, wait 2 to 3 minutes. Then repeat the priming and pumping until the fluid is clear. Next, bleed the rear brakes. With the ignition switch on, have an assistant depress the brake pedal and hold it down while you bleed the rear calipers in the conventional manner. Bleed the air from the HBB pump by turning the ignition off and pumping the brake 15 to 20 times until the pedal feels hard. Turn the ignition on and pump the brakes approximately 20 times. Then verify that the pump motor stops running. If the pump does not stop, you still have air in the system and you will have to bleed the air from the power supply. Bleed the power supply by connecting the scan tool. Turn the ignition on, then access the ABS actuator test menu. Wait at least 20 seconds between the following air bleed operations. Depress the brake pedal, then actuate air bleed 1. Release the pedal when complete. Depress the brake pedal, then actuate air bleed 2. Release the pedal when complete. Next, bleed the rear brakes. With the ignition switch on, have an assistant depress the brake pedal and hold it down while you bleed the rear calipers in the conventional manner. With the ignition on, bleed the air from each front caliper in the conventional manner. Turn the ignition off. Then pump the brake until the boost is exhausted and the pedal is hard. Add .3 or .4 brake fluid up to the max level in the reservoir. After viewing this section of the module, you should be familiar with the highlights of the HBB system bleeding procedure. Remember to refer to the service manual for the complete procedure. Diagnosis of the ABS system is very similar to previous models. The HBB can be checked for stored diagnostic trouble codes, and it has its own actuator tests. Here's a parking brake maintenance item that you'll really like. The parking brake adjustment has been moved into the passenger compartment. Just remove the cup holder and the adjustment is right near the brake lever. After viewing this module, you should be able to identify the proper way to service the HBB and locate the new parking brake adjustment. Refer to the service manual for complete service and adjustment procedures.